Gotcha. And I will put, if I ever forget to post the video, it is always on YouTube. I know some of you have found the videos on YouTube, so you can always go to my YouTube channel. Well, I'm glad you get to stay with us then, Natalie. All right, about 50 seconds. I'm going to go ahead and start. If you haven't yet started writing down, you're done with the warm-up and you haven't written down the essential question, I can statements, get that done. We are going to do some calculus today. I'm excited because we get to integrate. All right, here we go. So some reminders before we do get going. If you go to classwork, and I put up a whole bunch of, sorry, I posted a lot in the stream today because it was being dumb and not letting me attach a file. So if you click on AP Readiness, tomorrow is AP Readiness. Whether you signed up or not, you guys can go. You have to turn in, if you're gonna want the extra credit for in here, you have to turn in, did it not post the session 2? Apparently I didn't put up session 2 for your class. I need to put up session 2 for your class, but you should be able to post under session 1 and session 2. You just add your assignments there. You have to take a screenshot of the session, okay? And then plus you need to get, like, you know, scan your work just like you do your homework. Mr. Lundstrom is going to be there. So I highly recommend, if you look in the stream, the name of his sessions are there. And then he had the handout already, so the handout is attached right here, and then the links are right here. If you click on the agenda one, that takes you to the Zoom classes. You want to go to these two, one that says AM and the one that says PM. That's where I will be hanging out, okay? There are others, you're welcome to go to the others, but these are the two that I know are going to be good. Even though I know you may have seen them last year, it doesn't hurt to go back and see it again, okay? But you are welcome to do any of them. And then I did send out an email with to all AP students about whatchamacallit, like handouts for other sessions. There's a Dropbox out there. And then also don't forget when you get there to sign in, okay? Because that helps not only, that also is another way for us to check to see that you actually went, okay? So as they do that, plus the sign in from the, you have to sign into the Zoom call a certain way. All right, I'm just gonna go ahead and get started. We are recording today. So we're gonna just review the integration techniques we have so far, okay? So our essential question is, how do I identify the appropriate integration technique, okay? And then I can identify which integration technique to use. Is what we should hopefully be able to do by the end of the lesson. So we've studied a whole bunch of them at this point. These are some of the trickier ones that we've studied in the last couple of weeks, or the last week. And you'll notice that there's kind of a summary in the left-hand column there of all the integration that we have done. So there's a lot there. But we kind of spent this week going through all of it, and today we're just going to kind of try to bring it back together. If I had taught you, we were starting at school. This is probably, and we had done all of the curriculum last year. This is probably the first lesson I would have taught you this year. Okay, it's just getting the dust off the integration. All right, here we go. So we are going to do compare these three problems. Okay, so we've got three problems that look very, very, very similar here. So, and we had a bunch of techniques this week. You've got them all there in your notes. So looking at that first problem, looking at A, help me out in the chat. Tell me, what do you think, which integration technique do you think we're going to use on A? And you can flip back a couple pages in your notes and look and see if you can find it. And give everybody a chance to answer. Do we agree with Lorenzo? Which integration technique are we going to use on A? All right, so Lorenzo and Natalie both say that we are using arctangent, okay? So I am going to make an attempt to use arctangent. It isn't quite set up the way I'd like it. I would like to move that 4 out in front. So I've got 4, the integral of 1 over x squared plus 9 dx. I know that that is u squared and this is a squared. So u has got to be x and a has got to be 3. So, and I don't really have any u substitutions or anything goofy in there. So I'm just going to go ahead and integrate it. I'm dropping this 4. For arctangent, we know it's 1 over a, right? That's down here somewhere. It's right here. 1 over a. So I already have the 4 on the top. I'm just going to put my a on the bottom. So a was 3. Arctangent of u, which is the x, over a plus c. Okay. All right. What do we think about b? Which integration technique are we going to use on b? Tell me in the chat. I have 1 vote for u sub. Two votes for u sub. Nobody else wants to vote, apparently. Oh, 3 votes for u sub. All right, so maybe we should try u sub. Okay, so we've got u substitution here, or we're going to try u substitution here. So I'm going to try to use that as my u. I'm going to put it down at the bottom. So u equals x squared plus 9. That would mean that du has to equal 2x dx. I see x dx. I'm missing the 2. Or am I missing the 2? Could I rewrite this? Oh, I'm going to write that in orange, actually. I'll try to not do too many lines. All right. Could I rewrite this? I know I've got x dx as that part, but could I rewrite the 4 as 2 times 2? And I now actually have the entire u. All right, so I'm going to do my u substitution. At the same time, I'm going to move that extra 2 out front. So we've got 2 times the integral of, oops, still there, this. And I'm going to put u on the bottom. And then 2x dx is 1 du, or just du on the top. And then I'm going to integrate that. So I get 2, not that color. I want the dark blue. 2, and then 1 over u we know is the natural log of the absolute value of u plus c. And we're kind of getting out of the habit of writing the extra u line. We're just going to substitute in the x squared plus 9. All right, we ready for it? What integration technique am I going to use on C?
Ms. Ballard?
Oh, Natalie was trying to get ahead.
Ms. Ballard?
Yep, go ahead, David.
For B,
Uh-huh.
since there's 1 over u, so you wouldn't. So was there any case where you need to convert like 1 over u to like u to the negative first power?
That's the only one we don't. Okay. So
Okay.
let's look at why. So if you have u to the negative 1, I would be bringing when I integrate that and I add 1 to it, right? What do I get when I add 1 to it?
U 0.
0. Can we divide by 0?
No.
No, so that's the only one we can't bring the exponent. That's why we have natural log. Okay? All right. Do we agree with Natalie? Long division? I'm going to erase this. Need the space. All right, let's try it. Let's see if Natalie's right. So I'm going to put the 4x on squared on the inside and x squared plus 9 on the outside. Okay? All right, we have, how many times does x squared divide 4x squared? And we know it would go in there 4 times. I am going to go ahead and distribute. So 4x times x squared would be 4x squared. 4 times 9 would be 36. Technically, we've got 0x in there, but it's really not popping up, so we don't need to worry about it too much. I'm going to switch my signs. So I get a remainder of negative 36, and I'm going to put that over x squared plus 9. So I am going to redo my integral. Okay, so my integral is equivalent to 4 minus 36 over x squared plus 9 dx. I could rewrite that a bit, and I could say that as the same as 4 dx minus 36 on the outside, 1 over x squared plus 9 dx. And isn't this piece here, isn't that the same thing we had here? So it would be an arctangent on that piece. So we would have 4x off of the front minus 36. The arctangent, we're going to use the same u and a as we did over here. So a would be 3 arctangent of our ux over 3 plus c. You can simplify the 3 into the 36 and get a 12 if you want. You don't have to. Okay. But again, I think tonight's a web assignment. This is actually out of section 8.1. So we've moved out of kind of chapter 4, 5, 6. We're into 8.1 already. Okay, for this lesson. All right, we're going to try another technique just as a review. We're going to basically take 2 basic rules and combine them together for this integration. So when I see something like this, I kind of am starting to see something that looks archy, right? And then I see something, but it's not quite there where I need it. If I was going to pick on one of the arcs, it's starting to look somewhat like arcsine, okay? But it's not quite where it needs to be yet. So one way for me to deal with that is to take it apart into 2 fractions. And in fact, I tried messing with this one earlier in the video. Let's not do this because I don't think I assigned any definite. Let's just do it as an indefinite, okay? So we're going to integrate x over the square root of 4 minus x squared dx plus, I'm going to move the 3 on the outside, 1 over the square root of 4 minus x squared dx. So I took the fraction apart over the same common denominator. All right, what technique am I going to use for the front one? Tell me in the chat, what do you think we're going to use on the front one? All right, I'm seeing a couple of U subs. So it looks like we've got a U sub there. Oh, why am I writing U sub? I don't know. I should just be writing U equals. U equals 4 minus x squared, which means that du equals negative 2x dx. I have the x dx. I am missing the negative 2. So to add in the negative 2 on the top, I have to also have it on the bottom. All right, so we've got negative 1/2 in front. I'm going to sub in my u's. So I've got the u, square root of u on the bottom. Okay, so we're going to do a whole bunch at once. Let's see if we can do a whole bunch at once. I know I've got a u. Oh, I need orange. Okay, and I know that the square root is going to turn it to 1/2. To move it upstairs, I'm going to make it negative. Okay, so I did a whole bunch in one step there. For all of the light blue pieces, I am substituting in du. Looks much better than before, right? Okay, and I haven't even messed with this second half yet. So I'm going to go ahead and integrate that. So I've got -1/2 u. I'm not going to write, I'm going to try to shortcut it. U to the 1/2 power, because I add 1, divide by 1/2 or multiply by 2. I'm going to actually put my u in there. And then these guys cancel, so we've got negative square root of 4 minus x squared for the first piece. All right, the back piece is our arc sine, right? It looks identical to this guy right here. This is the a squared, this is the u squared. So if I was going to write down a is equal to 2 and u is equal to x. So we're going to have, well, I'm just going to go ahead and do the integration. So we've got 3. Arc sine, we don't have anything goofy out front. It's just arc sine of u over a, which is 2, plus c. And really, I have the same thing all the way to the bottom. Arc sine x over 2 plus a. Don't write the little squiggly, this guy here, okay, on the AP test. All right? That's not acceptable there. All right, we've got like 4 more examples we're going to get through, okay, just to get us a little bit of extra practice. All right, let's take a look at the next one. So example 3. What's example 3 sort of looking like? Tell me in the chat. Tell me what you think in the chat. Because we've been very quiet in the chat today. I'm not sure all of you were actually there. All right, I've got a vote for long division. What else are we seeing? What does that square root in there make you think of? All right, I've got a couple votes for arc sine. The weird part about this one, though, is that for arc sine, we need something squared, and we've got a squared on the top still. So there's something goofy going on in here, okay? So let's see, I actually have a u inside there, a u sub inside of an arc sine this time, okay? So if this was arc sine, I know that that's my a squared minus, I could write this as x cubed squared. So do you see the u that just popped up? So that's the u from, it's kind of weird, there's 2 u's. That's the u sub, that's the u that's inside there for the u sub. Okay, so let's use it as a u sub. So u equals x cubed. That means that du equals 3x squared dx. Do you see how I have the, I wrote a du instead of a dx. Do you see how I have the x squared dx piece? So all I need to do is add a 3 on the top and a 3 outside on the bottom. All right, I'm going to do my u sub in. So I have 1/3 the integral of the square root of 4 squared minus u squared. And then the whole numerator, the 3x squared dx, is all just 1 du. All right, I'm going to integrate it. I get 1/3 arc sine of u, which my u, couldn't I go ahead and do my u sub back in, over the a plus c. So I'm going to substitute back in that x cubed. Done. Hopefully not as bad as it looked to begin with. All right, we're going to see who actually paid attention and did their work yesterday. What do we think we need to do in example 4? I can see from the dead silence that you think we should do nothing. All right, that's exactly what we're going to do. We're going to do nothing. We're going to add 0 to it, which is like doing nothing to it, right? So we actually did this exact same example in your notes yesterday that you were supposed to take. So you should have known what to do. So I am going to actually add e to the x and subtract e to the x. So where I got that e to the x from was that I am looking at trying to do a u sub. If I've made that entire denominator the u, my du would be e to the x dx. And I don't have an e to the x dx because in the numerator without adding and subtracting e to the x, okay? So I have to add and subtract e to the x. I'm going to kind of group this in one-to-one group and that into another group, and we're going to write it as two separate fractions. So I got 1 plus e to the x over 1 plus e to the x dx minus, because of that negative, e to the x over 1 plus e to the x dx. Now everybody should be able to recognize this, and hopefully everyone's awake, okay? What does that reduce to? All right, I got 3 people now. Woohoo! 3 people. Okay. It reduces to 1, okay? And then this guy here, we can do our u substitution, can't we? Because we've got that as u. We have this as du. All right, so we've got we got u on the bottom, and then the e to the x dx turns into 1 du. I am ready to integrate. So when I integrate 1, we get x. And then when I integrate 1 over u, we get natural log absolute value of u plus c, and I'm just going to substitute my u back in, 1 plus e to the x.
Wait, Miss Ballard?
Yes, David?
From the part where you... Can you explain it again?
Yep. Okay. So I noticed that I tried to do a u sub to begin with, okay? So I chose 1 plus e to the x as my u. When I did the du, I have e to the x dx. I didn't have that in my numerator to be able to use that for the u sub piece. So I had to add it in, but if I add it in, I also have to subtract it. So that makes it add up to 0. So I'm not really adding anything to it if I add it and subtract it. Then I split it off into this first grouping as the numerator and then this group as the second numerator, and I split it into 2 fractions with the same denominator. My 1 plus e to the x divided by 1 plus e to the x equaled 1. Then I performed the u substitution over here with 1 plus e to the x as u and e to the x dx as the du. And then when I integrate 1, I get x. And when I integrate 1 over u, I get natural log absolute value of the u, which I subbed in, plus c. Are we good?
Or shouldn't the second e to the x be negative?
The negative got put out here.
Okay.
Okay. All right, we ready to keep going? All right, check this one out. Doesn't this look like fun? I think it looks like fun. Because guess what? It's a day that ends in y, so we need to do some trig. Okay. So anybody got I'm going to give you a hint. It is a u substitution. Anybody got any guesses on what the u should be? Oh, Natalie's been watching ahead. I think she watched my video already this morning. All right, so u equals the natural log of sine of x. Okay, it's actually going to be this one because we need to take the derivative, and we're going to wait. We'll just watch and see. It's going to be that. It's not just going to be the innermost inner. All right, so when we take the derivative, I get so we got to do the derivative of the inside and the derivative of the outside, right? Because we have a chain rule. This is a chain rule going on there. So the derivative of the inside is cosine. okay? The derivative of the outside is 1 over whatever's on the inside, sine x. And then we still have a dx after this. I know that we haven't typically done chain rule that way. We did a lot more steps. Again, we're going to try to reduce those number of steps for you as we get further in here, okay? So again, it was the derivative of the inside, which was cosine x. The derivative of the outside, which is 1 over whatever the mess is on the inside of that function, okay? So interestingly enough, I need cosine over sine. Do I have cosine over sine already there? Doesn't look like it, but I bet I could rewrite cotangent. Isn't cotangent cosine over sine times the natural log of sine x dx? So check it out. Let's see if we've got all of our parts. My u is this. My du is that. So I've got all of my parts. Isn't that nice? So watch this. We're going to integrate. For the orange, we're putting in u. For the blue, we're putting in du. Check it out. We can just add 2, divide by 2, plus c. Substitute that u back in. So natural log of sine x. Isn't that awesome? All right, you know what's even more awesome? We only have 1 left. Can you believe it? Only 1 left. Okay. Let's take a look at the last one. All right. Oh, goody, more trig. It's a day that really ends in Y, isn't it? If we've got 2 trig problems today. Okay, so I am thinking, I'm going to look through these things up here really quick. It says tangent squared. Go back to this list that we had here. We didn't have anything about tangent squared. We do know the integral of tangent itself, but we're going to see if we can find, let's see if that's even appropriate. I think there might be too much u subbing and all kinds of other strange things going on with this one. Let's rewrite this one before I get too far into it. This is really saying we've got the tangent of 2x and the whole thing squared. So really tangent is the inner function. So I am going to actually try to do something else with this other than just tangent. Let's start with the u sub. So let's start as simple as making u equal to 2x, okay? And then du equaling 2 dx. So let's see, I know I've got to get a 2 in there on the top and a 2 in there on the bottom to be able to compensate for my dx. So let's rewrite it. So 1/2 the tangent of u, the whole thing is squared, right? And then we've got 2 dx becomes du. So the catch is that I still have tangent squared. So I need like another u substitution, and that doesn't seem like a good thing to do on a Friday. Okay, all right. So let's try doing, instead of doing a u substitution, let's use some trig identities. That sounds like a lot of fun, doesn't it? All right, so do you remember that we have the pink signs? Okay. So that's the abbreviation for the pink signs, all right? And if I notice, this one here has to do with tangent and secant. So that's really that, right? So I'm going to solve it for tangent by moving the 1 to the other side. So I know that secant squared equals, I'm sorry, that's not what it equals. It's tangent squared equals secant squared minus 1. I know the integral of secant squared, right? That's pretty easy. So I'm going to substitute in, and I got to be careful about what I'm doing here. I'm going to take that tangent, that squared, and move it back in, because now you can see that it's actually tangent squared. Oh, I just erased all of it. That was dumb. Tangent squared. Okay, so it's tangent squared, and we're doing a direct substitution in for that whole thing. So I don't want you to tell me in like 10 seconds, because I know someone will, the squared disappeared. I'm substituting in directly for it. So I have 1/2 the integral of secant squared u minus 1 du. All right, when we integrate secant squared, okay, we get tangent of u. When we integrate 1, we get x dx. And then, what happened? Oh, I have to substitute back in my u. I'm like, where did the 2 come from? I have to substitute that guy back in. It wasn't x, was it? What did I do wrong? Mrs. Ballard, it is Friday. All right, so it's u plus c. Now we're going to substitute back in that 2x. So we've got 1/2 tangent. I probably don't need the parentheses, and I'm going to put 2x back in anytime I had a u. We making sense? It's just the inside function, Lorenzo. All right, and then down at the very bottom here, there are some, there's just a summary of all the integration techniques. It's literally just a copy and paste out of your textbook, okay? Are there any other questions, comments, or concerns? All right.
So Ms.
Nothing?
Ballard,
Yeah, what's wrong, David?
so when we find these trig identities,
Mm-hmm.
we're going to end up substituting, and so you still use the substitution, but we have to change the. Okay, so how come we had to substitute?
Because you had the 2 in front of the variable.
I mean, I meant substitute the tan for the secant.
Because there was no way to integrate tangent squared. We know how to integrate tangent. We know how, and if I had tried to do a u sub on that, if I tried to do u sub on the tangent, I would have had to take the derivative of tangent, which is secant squared, and I didn't have a secant squared sitting there to be able to do that with.
Okay.
Okay, makes sense?
Yeah, and for can you go back to example 5?
All right, what's your question on that one?
So so how come you have to? Can you just explain this one again?
Sure.
What are the part at where it says cosine over sine?
This part here? So I needed that part because when I took my du, I got, remember, I had to do a chain rule. So I had to take the derivative of the inside, which was cosine x. And the derivative of the outside is the 1 over the mess because of the natural log, so 1 over sine. I didn't have in my original cosine over sine, but I know if I use a trig identity, cotangent is cosine over sine. And then I did a straight substitution in. I've got u in for natural log sine x, and du in for cosine x over sine x times dx. And then I added the 1 to the exponent, divided by the new exponent, and then I substituted my u back in. Does that make sense?
Yeah.
Okay. Any other questions, comments, or concerns?
Mr. Bell?
Yeah, go ahead.
Hi. On example 6, when you replace tangent squared with secant squared u minus 1,
Yes.
why do we, when we did the integration with that, why do we replace -1 with u instead of something else?
Because when I integrate 1, it's like integrating u to the 0 power, so you add 1, right?
No, why do we integrate it as u instead of x or something else?
Because my variable of integration at that point is u.
Okay.
Okay?
Mhm.
Any other questions, comments, concerns? We're good? We sure?
Not guaranteed, but
Not guaranteed, but we think we're good. All right. Oh, I gotta go get that package. Hang on, I'll be right back. You guys, something was delivered for you. It's my house. Look, it says to 4th period calculus. What could it be? Oh my gosh, what could it be?
Something I'll probably never use.
Oh, I think you will use it. Let's see. What could it be? Oh, Annie, you want to help us?
Sure.
We're going to undo this package. I know you love packages. Help us out. See what's in there.
It's just 100.
Oh, we've got lots of paper. All right, hang on. I got to get the next thing open. Let's see. Oh, paper. Okay, let's see. What's this? Oh, it must be fragile. It's wrapped in paper. What is it? Integration with partial fractions. Oh my goodness, there's more. Oh my gosh. There's integration by parts. You guys are getting more integration techniques. Do you know how exciting this is?
Scammed.
More integration techniques are coming. They're coming on Monday. All right. So they're coming on Monday. You're getting more integration techniques.
I would have preferred.
We're finally getting to move into like the big integration techniques for BC calculus. Aren't we all excited? Don't pop those. I need those. All right. Yay, more integration techniques. I'm super excited. You want to see how excited I am? Check this out. Did you guys see the confetti? Did it go? Oh, I wasn't sharing my screen. Hang on. Well, I'll show you how excited I was because you have to see my screen. Look at how excited I was. Delayed suspense, right? Here you go. Woohoo! More integration techniques on Monday.